Well, I'm Matt Benjamin. I'm CTO of COHORTFS, and most of you probably don't know who we are, but we've been in the Ceph community for a few years. We're actually an Ann Arbor, Michigan-based startup that's focused on bringing new capabilities to parallel NFS to address new application workloads. And it came to be over time it started as an NSF grant-funded effort, and it came to be as well about extending those capabilities within the Ceph distributed storage stack, which has been an adventure. We're doing a number of things, but both in the file system layer and the block storage layers, the interfacing PNFS and Ceph. This talk is about a project we did in collaboration with Mellanox and with funding from Mellanox as the previous slides by conversation by Asaf explained from Mellanox, bringing the Ceph code base and adapting the Ceph transport layer to work with Excelio, which encapsulates the capabilities of RDMA InfiniBand and other transports that support RDMA. And the module that does that is called Excelio Messenger. Basically, this is which I'll explain. This is the transport abstraction that maps Ceph networking or Ceph messaging into Excelio, and via that into InfiniBand. Excelio, as Asaf explained, is a high-performance message passing framework by Mellanox, whose key benefit is to be an efficient adapter for InfiniBand RDMA transport. That typically traditionally used with MX interfaces. It's a wrapper for that, but as well, in future, this toolset will enable seamless mapping to other transports and multi-transport applications with policy-based failover and selection and other cool features. So the history is that this is work funded by Mellanox in support of customers using Ceph, with two key objectives really. One, increase the Ceph transport flexibility, simply add to the value that customers get from Ceph, but most importantly, to support efforts to increase Ceph IO performance. Ceph is already tremendously scalable horizontally, and perhaps more than other systems that we're familiar with. But one of the next frontiers of Ceph performance is to scale down to get optimal IO performance at the unit level. So briefly, what Excelio is. Some of this is information that overlaps in the previous talk, and hopefully will reinforce it. It's a high-performance, asynchronous, and reliable messaging library built with hardware acceleration and RDMA in mind. And so, as Asaf explained, it's a framework for building high-performance RPC transports. Since in particular, it's a messaging sort of API framework, which is a very, very good fit with Ceph, since that's actually Ceph's internal structure as well. Currently, as we've stated, it's supporting RDMA transport, but in the future, and that future is coming quite quickly, it's going to encapsulate multiple transports. Some key features of Excelio. As a streamlined and but also flexible selection of messaging models, so it can be response protocols and one-way protocols with strong delivery semantics are supported. Of course, it supports zero copy to the core. It's essentially nearly lockless internal message path, including all the support areas that are tough to do when you're rolling your own RDMA applications like lock-free memory allocators and so forth. It's optimized already for thread CPU parallelism, NUMA, with a lot less involvement from the application. Some facts about the Excelio roadmap. We're currently sort of approaching or just crossing the Excelio 1.1 release. Excelio has been used for over a year. It's some customer applications and prototypes. 1.1 has, in addition to a stream of bug fixes and improvements from all over the Mellanox Excelio sort of code base, it has a number of improvements or adjustments that are designed, or enhancements that are designed to support Ceph specifically. There will also be sometime in fall, probably I'm guessing it's a 1.2, but I didn't have a chance to confirm version numbers with anybody. A significant point release in fall, one of whose key features is expected to be TCP and possibly other transport support integrated into the stack, and probably, we're hoping, some additional interface adjustments that allow us to do more advanced features in channelization and flow control at the application layer. We can take direct advantage of in our Ceph.
Switching the cables over, but I'll be fine. I just want to give you the
just to give you a
opportunity.
really broad sense, and these are based on informal numbers that I have from Mellanox internally. It's available performance measurement on
Giving you the
a
opportunity.
relatively standard Mellanox and modern Mellanox switching infrastructure and HBAs, MX3. It's capable of up to 3 million IOPS on such equipment. So the round trip messages between two processes on two machines, or even the same machine. It can essentially saturate single port FDR and probably higher, but I've seen it do that. And benchmarks to prove that you can run it. You get a sense of what it can deliver for your application or on your particular hardware, and assist with testing your hardware and understanding its throughput. Come with Excelio and a bunch of different configurations for all the API message passing styles and so on.
Could you plug our specific SSD?
So news about what Excelio is and what to do with it. So the source code is available there.
It's all HT.
Excelio's
one
GitHub.
I just say, hey, we've
as
got
we noted earlier
experts
in
back
the
there
day,
and all our technologies.
it's been being made available by Mellanox under a dual license, PSD and GPL. So it's capable of being integrated into essentially anything, and it's less expensive projects free and commercial. There's a cool white paper that's also available. I'll also link to here.
So here to help me out are all
by
my
Mellanox.
buddies there.
It's sort of a sales pitch on
when I cue you.
the scope, where it's going, and some more details about how it looks to build applications with it and what features it's going to support. So then, and the Ceph side, the Excelio Messenger is this adapter to Excelio for Messenger, which is the abstract sort of transport, top-level interface for Ceph's transport layer. In that sense, it's a drop-in replacement or an alternate, or essentially an alternate when you want to use it by side for what's called a simple, what the class is called Simple Messenger today, which is the current TCP messaging encapsulation. But it takes, which is objective is to take full advantage of Excelio. In particular, in this level of the prototyping, it should do full zero copy, and it should get strong parallelism across multiple threads in the application and server, in the client and server applications. And I'm going to talk a little bit about internal stuff, and if you're a Ceph developer or interested in Ceph internals, you get a little bit of a sense of how things are constructed in there at the messaging layer. And if not, sort of tune it out and just pretend it's cool. But inside of Ceph, when you're looking at there's actually really nice abstraction inside of Ceph for transport capability, even though they only had one implementation to start with, which is a good sign in any software project. The messenger is the abstraction that represents a bidirectional communication endpoint. So basically, a client or server has a messenger, and its subtype defines what kind of transport it's going to use. Messengers exchange information for connections, which is an active communication channel with some other endpoint. Which we could have been a client talking to a server to get one, or the reverse, and there are connections that loop back through the message stack without encoding data. So it's an active communication channel. It supports order delivery in its full form. It encapsulates flow control and rate limiting that guarantees a Ceph cluster can remain responsive even under heavy load from an arbitrary numbers of clients. We don't have full support for that in Excelio Messenger. That's getting there and building next generation interfaces for all transports in Ceph is part of the forward process for this effort. Also Messenger supports or Simple Messenger currently, strong endpoint identification and wire encryption using a host credential. So this is the CephX that Sage talked about. We also don't have CephX in Excelio Messenger. We'll probably want to abstract out some implementation that allows all messengers to share a common implementation. But a message also, though, of course, is the actual request or reply going, or other message object being sent over the connections, and it serializes or deserializes. Using common code, encode and decode mechanisms that are in Ceph and other primitives. So we reuse all that code, in other words, in Excelio Messenger. So Excelio Messenger implements this messenger interface. It encapsulates the Excelio pieces. It deals with connections and other Excelio abstractions that are sort of underneath that. It deals with the event loops and other mechanisms that are part of a Ceph communication channel. And provides interfaces for selecting those and setting those up for a particular daemon's requirements. It has a connection, and there's also a loopback form, which the TCP messenger also has. Just to give you a sense of that, This is how things sort of stack out, and this is sort of a representation of how XIO Messenger is able to fit in to the current architecture. There's some amount of refactoring of the Ceph code base that I showed in orange in the middle. That's actually being upstreamed into code targeting Giant now and under WIP, I think it's WIP XIO. So this work is going forward, and it aims to pull out the common pieces of simple messenger and more cleanly, so that all messengers could and related classes can use those. Some things that are some sections that are worth looking that I wanted to bring. I'll just bring in as for informational purposes. One of the points that Asaf mentioned is that XLIO aims to deliver sort of optimal thread parallelism for a particular application. It does that by understanding sets of CPUs that it's going to use in constant for parallel transition. And when it wants to do that, it has memory associated with each of those CPUs and so on. One of the ways that it develops thread channels across a pair of endpoints is using an object called a portal. So we have an abstraction for that. It's less granular. It's smaller than a connection. It's less granular than a connection, and there will probably be more abstractions like this to encapsulate channels or flows over the interface as well. I'll kind of skip through this, but there's various abstractions that we set up in order to get one of the main, I guess, stepping back, one of the main activities I found myself involved with was mapping the sort of thread context and thread activity of different clients and servers inside of Ceph, which are heavily threaded in various different ways, differing by daemon and client and so forth, with XLIO, which has a fairly restricted model for concurrency that's aimed at maximizing throughput. So here's some of the abstractions that enable a set of Ceph threads to efficiently dispatch into XLIO, and deal with consistency there with minimal sort of locking and bottlenecks. We've measured pretty good performance results, so we think we've done a pretty good job with that. And I won't go into it, but the sort of construction, the sort of use of various helper types and so forth is documented here. Basically have various bits of tracking information that follow Ceph messages in and out as they're encoded and decoded that allow us to associate those pieces with XLIO primitives that are coming in and out of the endpoint. So something that's the most complete thing you can work with today is XIO client and XIO server. These are basically Ceph versions of the benchmarks that XLIO provides to test to benchmark the throughput of a client and server in different modes. And these Ceph versions of these are standalone programs that allow you to select various details about data sizes, and other connection information, and run between various endpoints. Very simple client-server workloads, which show that we get relatively reasonable performance. These performance results aren't great because they're on untuned equipment whose maximum available bandwidth was about 3.4 gigabytes per second, and over within Mellanox they get twice that, and a machine which with XLIO benchmark programs can get about 1 million round trip operations per second, and so given that within that frame. We get about half that number of IOPS with the smallest available message sizes. So we're within 50% of optimal as far as we can tell with available bandwidth of XLIO, available IOPS, and roughly the same. We're almost saturating the available bandwidth of XLIO at a 64K message size. Over within Mellanox, these numbers have hit 6 megabytes per second, 6 gigabytes per second bandwidth. I haven't seen the IOP numbers, but I think they're comparable. So I think we're getting 1.5 million IOPS with small messages. So these performance results, in other words, are promising. They're adequate to deliver a lot of value in a data center once the rest of the code is stabilized. So what is that status? We have the working messenger stack that was originally done on Emperor and has been pulled up to Firefly and hasn't been re-benchmarked there. Those are Emperor numbers. It's been integrated with all of the Ceph daemons and clients. Some of them can be used together. There are a few blockers or issues working on to get a complete cluster running on Excelio, it is possible to run Rados over it from a client and to run Rados workloads. We have some Rados additional numbers for that, which would show that for a few workloads, for a few kind of operations that's especially heavy reading with large blocks, we get a lot of bandwidth. There are other bottlenecks left in the Ceph stack, OSD data path and other things to work on. But we're also working on those as our InkTank. So we're doing it. And we're actually and in tandem with performance work, we're polishing off remaining issues to make a full cluster environment available during the course of the giant release. If you want to get the stuff, as you know. Asaf mentioned, it's all the intention of is for all to be in the box, but of course this is development. So at this stage, you get it on the internet. From Excelio, if you're actually going to experiment with this, which I think the code's ready to do, you have the Excelio branch that targets us, the one that was targeting the 1.1 branch. I don't think there's been a full release or an official release yet. So 4_next is the branch that has Ceph compatibility, and our we have two sets of branches on our external Ceph repositories that integrate all of this. One, Excelio Firefly works, has differing only by not by features, but only by builds.
Get a picture of me because I got a tweet as well.
We are CMake users internally, and since we can get on machines with lots of cores, we can build Ceph much faster. So we have maintaining CMake branches that in parallel. There's also more importantly,
I just need the same picture so I can retweet it.
It's probably at the end.
Lots of
The
acronyms.
upstream branch that was slowly merging into Ceph is called WIP-XIO, and then of course is an official upstream branch. The current tip of WIP-XIO, I believe, is merging in interfaces and sort of refactoring, and eventually it'll have all the changes here plus probably more. Just some notes about how to run these. If you're actually interested in running the client server test programs on InfiniBand enabled or RDMA capable hosts, you only need to make small changes to your config file, set your ceph.conf to make sure you can identify on each host an appropriately RDMA accessible endpoint, which uses TCP for identification. If you use cluster RDMA and client RDMA tags, it's going to attempt to bring the entire cluster up using XIO as the main transport, and we'll attempt to use XIO for cluster communications. So limitations of this as it is today. Well, in the current design step, we don't have CephX. So the goal eventually we will support that, but it's not there yet, and probably for the next little while, the main uses won't really demand it. But eventually, of course, that's planned. There is a bunch of logic and a bunch of intelligence in the Ceph networking that deals with resilient operation of the network fabric under insane conditions. Ceph pays a large penalty to do that, but it gets a lot out of that. Obviously, resilience is a huge value. Some of that stuff is not yet exposed fully in XIO, but how we'll get that, and how we'll get that with the cleanest architecture, with the best layering of the underlying transports and the messenger is part of the development that's going on right now. And upstreaming, as I said, I'm glad I have a slide. WIP-XIO, if you're out on the official Ceph GitHub, you'll see that branch there. Sage maintains that branch and is bringing in pieces as we prepare for the next release.